好，各位同學，大家好啊！今日係2020年9月10號啊。咁我哋關於Uniform Circular Motion 最後尾一堂嘅課堂咧，依家就開始啦。咁我哋最後尾一個狀況咧，要討論一個situation 咧，就係嗰啲電單車或者單車咧轉彎嘅時候嗰個單車同地面vertical 所產生嘅 angle 同嗰個轉彎咧有咩關係嘅 ？OK 啊？好啦，咁喺呢一度咧就當個單車bicycle 或者係 motor bicycle 去轉彎啦going to make a turn 啦，咁咧佢就一定咧就如果我有咁上下速度啦，佢就咧 lean to a direction， 又 lean to the centre of revolution 嗰邊嘅centre of revolution 嗰邊，咁咧佢架車就可以咧即係穩定地咁樣啦，係咁樣轉彎嘅咁樣嚇 ，OK 咁我而家又問嗰個 angle 咧係點樣影響啊？如果大家有睇嗰啲嗰啲racing 啊，即係motorbike racing 嗰啲啦架車咧嗱，如果佢轉彎嘅時候低得滯咧，佢架車就會瞓落去一個人，成個瞓咗落去，咁啊線出嚟啦嚇。亦都有啲情況咧，佢轉彎嘅好高速啊，佢轉得唔夠低，好似咧有人咧拎起嗰個人咁樣嚇，將佢咧拎到反轉呢一邊咁跌落去 ，OK， 即係本來咁樣轉緊彎嘅，但係咧佢 angle 唔夠啊，即係話速度太高，平衡唔到啊，咁佢咧就會反轉嘅架車 ，OK， 反翻佢，好似俾人哋揭起個蓋咁樣嘅嚇 ，OK 嚇，咁啊 lift it up 啦，咁啊就係 turn over to the other side 咁樣㗎 ，OK， 好啦，咁簡單嚟講，我哋就問一問，即係一個motorcycle 或者係cyclist， 即係嗰啲單車手或者電單車都好啦。咁佢哋轉彎嘅時候係靠咩力去 provide 嗰個 centripetal force 咧？呢個第一點嚇。OK 邊個乜嘢力 provide centripetal force 嚇？好啦，咁要答呢個問題咧，就要畫 free body diagram 啦。咁我哋咧就畫咗呢個人啦，係咪？咁呢個單車啦嚇，單車咁佢咧就黐住個地下，所以地下咧就提供咧垂直方向嘅力 normal reaction。第二咧就垂直提供打橫嘅力 friction。OK， 咁第三咧嗰個人咧就俾地球拉住啊嘛，加埋架車，即係個人加埋架車，兩個加埋一齊考慮啦，我哋嚇。咁咧就有佢個 weight 係嘛？好啦，咁大家睇到 weight and normal reaction are in the vertical direction。咁 that's why， 所以咧只有咩咧？只有 friction 咧係 in the horizontal direction， 即係呢一個即係話咧 in 呢個 case 咧即係 friction 咧去 provide 嗰個 centripetal force。O 唔 OK？ 嗱呢個冇第三個 force 噶啦，得唔得？嗱 free body diagram 首先分析咗咩 force 先嚇 ，OK？ 咁所以呢一度咧就係 friction。OK？就 provide centripetal force。咁this gives a turning moment on the bicycle to make the bicycle overturn anti-clockwise。好啦，咁係咩意思咧？咁樣嚇，好啦，咁如果咧，我哋依家咧就 take moment about 佢個CG about 嗰個 centre of gravity 或者 centre of mass。OK， 即係 take moment about 呢個 point 呢個 point CG。好啦，咁呢一個力friction咧就會產生一個 moment 咧，就令到個 friction 就令到嗰個人同埋架單車一齊就 turn around in the anti-clockwise 嘅 direction， 就咁樣係嘛？有一個 turning moment 得唔得？好啦，咁咧如果淨係得呢一個 turning moment 嘅話咧，嗰個單車就會咁樣，因為呢個摩擦力喺底下，即係伸過去摩擦咁樣咧就拉住佢跌低嘅，成個人就會咁樣跌低。OK， 好啦，咁所以咧要令到呢件事唔跌低，佢可以穩定地轉到個彎咧。咁 to avoid overturning， 即係 avoid overturning 啦，即係咁樣反車反翻轉頭。咁咧嗰個 bicycle 咧 has to lean。OK， 咁lean 咧就會係倚靠靠向邊一邊咧靠向邊一邊。OK， 咁填翻個方向就得啦。OK， 咁呢度咧就係。好啦，咁咧要 lean to towards the centre of revolution， 即係咧向嗰個旋轉嘅中心點centre of revolution 或者係 centre of rotation 咧向呢邊咧咁啊倚靠過去。OK 嚇得唔得？好啦，咁啊以下咧就係一啲數學嘅分析，我哋要問一問嗰個 angle 靠落去嗰隻 angle 啊，即係我哋依家嗰個筆記嘅呢一隻角度個 theta 呢一隻角度係同咩有關咧？咁樣嚇OK 呢個 angle 係同咩有關咧？咁樣得唔得？佢係靠咗去嗰邊，咁呢個 angle theta 係同咩有關咧？咁樣好。好唔 OK 啊，同學？咁你知道大家我哋想做啲乜嘢啊嘛？係咪？就係理論上去討論嗰隻 angle 同咩係相關嘅得唔得？咁我哋就喺黑板嗰度做啦。好啦，我哋咧就畫翻嗰個 diagram 出嚟先啦，係咪就跟翻嗰個筆記啦咁呢個咧就係嗰個 cyclist 啦呢一度咧就有 normal reaction。CG 嗰度咧就係個 weight 啦咁然後咧 horizontal 咧就有 friction 好啦，咁呢一度咧呢個 O 點咧就係 centre of revolution。好啦，依家佢問咩咧？就問呢一個 angle theta。OK 又或者喺筆記度咧，即係呢個 angle theta。個 lean an angle to the vertical， 個 lean towards 咩 ？towards the centre of revolution，the centre of rotation。Michelle，家姐，就幫我拉呢個簾啊，唔該，thank you， 小心啊，剝咗依一封先。好。好，咁我哋咧就有兩個dimension 都要講嘅，就係咧嗰個人嗰個 CG 咧，距離地下咧係幾遠嘅。咁啊嗱，睇翻筆記呢兩個數字我哋係需要嘅。咁咧亦都同佢嗰個 leaning 係相關嘅。如果架車嗰個人咧就好矮嘅，咁好貼地嘅同個身高咧好高嘅，咁嗰個 angle 咧係會有受影響嘅。呢度講緊咩咧？就係呢個 CG 咧去到地下嘅距離就呢一個H。咁第二咧就係個 CG 呢個位咧同個 normal reaction 之間呢個距離 ，OK 呢一度得唔得？呢兩個位，一個咧叫 H， 一個叫 D 嘅，咁你掹埋呢兩個位先OK 即係咧呢一度CG 去到呢個地面，呢個叫 H。呢個 weight 啫，呢一度去到呢個 normal reaction 嘅距離咧，我叫做 D 嘅，得唔得？好 ，sorry。好啦，咁我哋咧就個 F 咧就提供嗰個centripetal acceleration 啦，係咪OK， 咁所以咧先我哋頭先咧就話嗰個 moment， 我 take 咗 moment 先等大家清晰啲我哋頭先解釋過，因為呢個係 CG 啦，係咪？咁呢個 force take moment about CG 呢個 force 咧就提供一個 clockwise 嘅 moment 啦，係咪 ？clockwise 嘅 moment。咁所以咧，我哋咧首先做呢個先咁就 take moment about CG。OK。咁嗰個 anti-clockwise moment 咧 provided by friction， 就 friction times 嗰個 moment arm 咧就呢個距離，呢個垂直距離啦，就 moment arm 啦，就 H。OK， 咁等於咩咧？呢度提供一個 anti-clockwise 嘅 moment。咁at the same time 咧， 呢一個 normal reaction 咧，就有個 moment 咧，就包呢個 CG 嘅，咁咧就係一個 clockwise 嘅 moment。OK， 咁如果佢呢兩樣嘢係啱啱 balance 嘅話，嗰個人咧就可以咧就穩定地咧就咁就轉到呢個彎，就唔會咧第一跌落去啦，或者咧咁樣 overturn 啦嚇，咁總之就唔會啦，佢都可以穩定啊，即係唔會 overturn to either direction。OK， 咁所以呢一個咧就係 normal reaction。我乘翻咩咧？就乘翻個 D 嘅。嗱呢個咧就係嗰個垂直距離啊嘛。啊，如果大家唔記得，翻去温習啦。moment of force 咧就係 force times moment arm。咩叫 moment arm 咧？就係個 force 啊。呢個 force 去到嗰個轉軸，呢個轉軸就係呢個 CG 嗰個垂直距離啊 ，perpendicular distance of the force to the turning axis。呢個 turning axis 喺呢度得唔得？咁所以咧就係呢個 D 嚟嘅。啊，呢個 D 嚟嘅 ，OK， 咁我哋要問呢個 angle 啊嘛，係咪？嗱，呢個 angle 啊，大家睇一睇啊 ，angle 啊，如果我哋畫呢個直角三角形喺呢度，喺呢度呢個 angle， 咁呢個直角三角形，咁呢度咪 D 咯，啊呢個長度咪 H 咯，係嘛？所以 D over H 咧，即係呢一段除翻呢一段咧，啊呢個 D 除翻呢個 H 咧。啊 ，D 除 H 就係我哋嘅 tangent theta 係嘛？呢個 tangent theta 就係呢個 D 啊。OK， 嗱 theta 呢度即係呢個 theta， 呢個 theta 即係呢個 theta 啦，喺呢個直角三角形嗰度啊。呢個係 D， 呢個 H 得唔得？tangent theta 就 D over H 咯 ，tangent theta 就 D over H， 即係呢一個除呢一個，得唔得？好啦，咁 D over H 咧，啊 D over H 咧，啊呢個走過去，啊呢一個走過嚟，係嘛？咁啊等於 F over N 啦，得唔得 ？OK， 好啦，咁喺呢一度，我哋就揾出嗰個 leaning angle 同埋呢個 friction 同埋 normal reaction 嘅關係啦。咁呢個step one 啦。好啦，咁啊 step two， 咁我哋咧就頭先講咗啦 ，take 咗 moment 先啦，係咪？咁啊其實咧仲有兩條 equation 嘅，我哋不嬲都要做噶啦，係咪？嗰兩條 equation 係咩啊？就係咧考慮 horizontal direction， 就 F 等於 ma 啦，因為呢個單車係咁樣喐緊啊嘛，咁樣。
Mr. Kong，
係請講。
There's someone in the waiting room.
Sorry.
There's someone in the waiting room.
Sorry, would you repeat?
You need to invite Giddy into the Zoom meeting.
Oh, yes. Sorry. Yes. Okay, thank you so much. Thank you for your reminder. Okay. Once again, I repeat. Okay, from the diagram, first of all, we relate the angle of leaning, which is towards the center of revolution, by taking the moment about the CG. Whereas we have two simple force in this case, because the force, the weight passing through CG, does not provide any moment of force. In this case, moment arm is 0, right? And the friction will cause the cyclist to have a anti-clockwise moment like this. Okay, and the value of the moment of force is F times this perpendicular distance H. Okay, and the anti-clockwise moment provided by the normal reaction, this force, normal reaction is N times D. D is this one. The perpendicular distance, this one, to the turning axis. Okay, and the angle, the tangent of the angle in this simple right angle diagram, right angle triangle, tell us that the tangent of the theta is D over H. Okay, D over H. And with this, we rearrange the term D over H means equals to F over N. Then what is F and what is N in this case? Okay, in the normal in the horizontal direction, we make use of what we have learned in the previous lesson. We have F equals to ma, but F equals to ma, which is Newton's second law of motion, right? And we have friction, which is the force, the net force. In this case, for y, centripetal force. And so we have mv squared over r, right? And then in the vertical direction, we have one force acting on the cyclist is normal reaction. The other is weight. And there is no other force except these two. And it means that in the vertical direction, these two forces cancel out each other because there is no acceleration in the vertical direction, right? And by Newton's first law of motion, net force is 0, and these two forces balance each other. And so we have N equals to W equals to mg. So once again, F is equals to mv squared over r, okay? Net force for y, ma. And then normal reaction in the vertical direction equals to the weight of the cyclist. So we have tangent theta equals to v squared over rg. The same expression in the case of banking the bank of designing the highway for vehicle, okay, transportation, and also the case for airplane to make a turn, okay. So any questions? Okay, if not, there are some exercise at the end of these notes. They are extracted from some university textbook and are suitable for you to do some more exercise. All right, so today I would like to go through some of them. All right, and you are required to finish all of them by yourself and hand it to me after school, normal school resume. All right. So the first one. A rotating fan completes 1,200 revolutions each minute. Calculate a point on the tip of the blade of the fan, which has a radius of 0.15 meter. A, through what distance does the point move in one revolution? Oh, part A is quite simple, right? But we will deal with them one by one. Okay, I have a fan here. Okay, we have an electric fan. Suppose it is rotating like this. Upon at the tip of one blade, 個線葉啊 blade，OK blade 咁啊 radius 咧就係 0.15 meter。好啦，第一個咧就問佢嗰個一個圈the distance travel by this point in one cycle, one revolution, which is the circumference of the circle of the radius of 0.15 meter. Very simple. Right? So the answer is and secondly, point B, you are asked to find the velocity of this point, this particular point. And by using this one, you can find the linear speed of the point. Before that, we need to find the angular speed of the whole system. Okay? And omega can be obtained through this figure, this number, which tell us that the rate, the blades, the fan rotates at 1,200 revolutions per minute, right? And so omega is 1,200 revolution, 1,200 revolution. And for each revolution, it makes a turn of the angle of 2 pi radian, right? In 1 minute, 60 seconds. And so this is the angular speed obtained from this unit, which is revolution per minute. Revolution per minute. We change this unit into radian per second. Radian per second, right? So with the help of the calculator, okay, correct me if I'm wrong, right? So V now is equals to R omega and 0.15 times 125.7. Okay. So the answer should be 18.85 meter per second. And part C, you're asked to find the acceleration, right? Acceleration equals to R omega squared, which gives you 1,000 upon 15 times this value. Oh, sorry. Uh, 2,370 meter per second square. Let's see, all the numerical answers are provided in the exercise, okay, in this exercise, and you can check this out by yourself, okay. This exercise are for self-study, okay, self-study. Right? And the number should be correct, 94.2 and 80.4 5. Okay, it should be correct. Okay. Okay, since the time is not too much, I would like to do one exercise which are more difficult. Okay, and I skip the easier part for you to complete by yourself. And at the end of this suspension of school, please hand in the solution of this exercise, and that means that you have already 3 assignment altogether, including this. Okay, including this one. All right, 3 assignment. Okay, 3 separate assignment. And please note that question 10, this one should be omitted. Please cross out question 10. OK， 呢個唔需要做啊，同學。呢個我哋冇講呢一題嘅，呢一題就out of syllabus唔需要做，得唔得？第10題唔需要做，其他啲幫我做，好冇？咁我依家咧就講比較困難嗰一題，就第9題啊嘛。我要講比較困難嗰一題嗰啲題目淺嗰啲留翻俾大家自己做啦之前嗰啲比較淺嘅咁我就唔做俾你睇啦。咁因為今日最後尾一堂我哋下一堂就要講gravitation 㗎啦。OK， 咁大家睇一睇題目先，我刷一刷版先好啊。OK， 好啦，同學嗱，呢個題目咧就即係比較困難嘅。咁我哋就話咧，a ball 咧 1.34 cubic 咁attached to a rigid vertical rod 啦，呢條 vertical rod 咧喺度轉緊嘅OK， 咁咧佢就有條繩啦，嗰條繩咧就整咗一個咧equilateral 嘅 triangle 得唔得 ？equilateral triangle 呢度 forming equilateral triangle with the rod。咁呢幅圖咧就 show 咗啦。咁個 upper tension 咧就係 35。OK， 咁問咩咧 ？A find the tension in the lower string。咁問 A T2係乜嘢 ？OK 咁嘅 B 咧就問 calculate the net force on the ball。B 就問 net force。OK， 咁C 咧就問咩咧 ？C 咧就係問 calculate what's the speed of the ball？V of the ball。OK， 咁我哋翻黑板呢度咧就睇完啦，係咪？大家得唔得 ？OK 啦，好啦。咁因為咧just because this one involve the calculation of force and it means calculation of vector. So it's quite difficult questions. And first of all, we draw the free body diagram in order to solve question like this. Okay, any question like this, draw free body diagram. All right. Tension 1, tension 2, and then the first force should be this weight, which is mg, right? And so first, we resolve the forces to vertical direction and then horizontal direction, right? and it means vertical and horizontal direction. For the vertical direction, we have T1. Now that this angle is 60 and half of the angle, okay, because this is a bisector, this is a symmetrical system. And so this angle should be 30 degrees and the lower angle also 30 degrees, right? And so with respect to this angle, the vertical component should be T1 sine 30 degrees, right? And the lower one should be T2 sine 30 degrees. Is that correct? Pose your questions if you have any. And then the horizontal one would be T1 cosine 30 degrees. And the other one, this one is T2 cosine 30 degrees. Okay, now I draw a simple diagram once again. Okay, vertical forces, there are three. One, T1 sine 30 degrees, and T2 sine 30 degrees downward, and the weight downward. Okay, and so when you are asked to calculate T2, we can make use of this one. Okay, and because vertically, T1 sine 30 degrees equals to T2 sine 30 degrees plus mg, right? Is that correct? Because there is no motion in the vertical direction, no acceleration. So by Newton's first law of motion, net force along the vertical direction is 0. And it means that this force, T1 sine 30 degrees, is to be balanced by T2 sine 30 degrees and the weight of the ball. All right? So we have this expression right here. And so T1 is 35. We have 35 sine 30 degrees equals to T2 sine 30 degrees plus mass 1.34. 1.34. And I will use 10. Okay, for G. Never mind, you can use 9.81. That should be perfectly correct. Okay. 3.4. All right, let me check the answer first because all the numerical answers are given, are provided, right? 8.2 Newton. That's correct. All right. This one, 8.2 Newton. That's correct. Okay. Now we should move on to part B. All right. Part B. Part B. Erase. part B 問咩啊，朋友 ？part B 問咩啊
part B 問點解呢題叫 part B？
哦 ，calculate net force on the tension。OK， 咁啊，跟住 C 就問個 speed。OK， 得 net force。好，好啦 ，part B 呢個 A 啦，係咪 ？part B 咧，其實就問咩咧？邊度有 net force 咧？
我哋揀分科
就係垂直啦，啲 force 就 cancel out 啦，所以垂直個 net force 係0啦。 所以咧剩翻嘅 net force 咧就係 in the horizontal direction。咁啊 in the horizontal direction 咧就有兩個 force， 一個咧就係呢一個啊，就係 T1 cosine 30 degree。第二個咧就係呢一個啊，就係 T2 cosine 30 degree。所以咧個 net force 咧就只係 along the vertical direction， 而且咧就 pointing to this 呢個係 centre of revolution 啦，係咪？呢個波繞住呢個點喺度咁樣轉啊嘛，係咪？咁樣轉啊嘛，兜喺度轉啊嘛，係咪？個 net force 咧就呢兩個相加，就係 T1 cosine 30 degrees plus T2 cosine 30 degrees， 得唔得啊？T1 咧就係35啦 ，T2 頭先計咗啦係 8.2 啦，係咪？咁啊乘翻 cosine 30，咁呢個就係 common factor 啦，抽。